Hello guys. Today I solved the trigonometry puzzle or right triangle puzzle today. And I was only given that figure ABCD is a square. Segment AP is equal to 5 centimeters. Segment QC is equal to 7 centimeters. And segment PB is equal to 12 centimeters. And I had 5 problems to do with just this given information, which took a long time. But anyway, let's move on. Number 1 says find the measure of angle. Okay, never mind. If you want to continue to hear how I did my problems, go on. If not, just tap exit and be sure to subscribe to my channel. Okay? Anyway, find the measure of angle X. Please round to 1 decimal place. For this one, I used the inverse sign to find the angle because that's how we do it. To use it, I used the sine of x equals opposite over hypotenuse, where the opposite is 5 and the hypotenuse is 12. So the sine of x is 5 over 12, but I can't do it that way, so I use inverse sine 5 over 12 in parentheses equals x. For this problem, I got 24.6 degrees through just typing the inverse sine function right over here into my calculator. And now number 2. Find the length of side AB. Please round to 1 decimal place. I use the Pythagorean theorem, which is right there, where A equals 5 and C equals 12. Interestingly, A is AP and C is PB. So I did the plugins and basically solved it like an algebraic equation, square rooted it to get 10.9 centimeters, and that's done, and that's it with number 2. For number 3, which I consider the easiest because it seemed the shortest to me, here's how I solved it. I did 10.9 equals, actually no, I used the formula DC equals DQ plus QC, plug numbers, which is 10.9 and 7. 10.9 is DC and 7 is QC actually. QC, it's the way I did it, and I solved it algebraically to get 3.9 centimeters for segment DQ. Oops, my bad again. For number 4, you need to find the length of side PD. You need to round to 1 place. For this, I use the formula AD equals AP plus PD, where AP equals 5 and AD, or DC, where DC equals 10.9, AD is congruent to DC. So AD is 10.9. So I did 10.9 equals 5 plus PD. I solved it like an algebraic equation, as you can see here, and I got 5.9 centimeters. And now here we are in the trickiest of these problems and the hardest. It was basically difficult because it was tricky. And here's how I did it. Now I put a lot of given information here and I used it. And anyway, here's the problem. Find the measure of angle BQD, and you have to round to 1 decimal place. First, I did the inverse tangent to get angle PQD, and to find the angle, I had to use the angle addition postulate. So I needed to find both PQD and BQP before finding BQD. So first I found PQD with the inverse tan function right there, and I got 56.5. Then it is PQD. Don't neglect this because you will need it later on to understand. Anyway, moving on. 180 degrees equals 90 plus 24.6 plus APB. I used that for triangle PAB and then solved it that added 90 plus 24.6, and I solved it algebraically to get 65.4, which equals APB. Then I did 180. Then I did triangle DPQ, which is this problem. And I was basically trying to find angle DPQ because I thought that would help me. And anyway, I solved it algebraically and I got 33.5, as you can see closer, as DPQ. Then I did then to find angle BPQ, I did the same supplement thing for 3 angles since it is a linear pair. Added 90 plus, added 65.4 plus 33.5 to get, and subtract that from 180 to get 81.1 degrees, and that equals angle BPQ, as you can see here. Then I took a look at triangle BPQ. I bisected it and made an imaginary angle, which is basically the half of angle PBQ, and then I did solve for the imaginary angle. So I did 180 equals 81 plus 90 plus imaginary angle, added 181 plus 90 to get 171.1, so I have 180 equals 171.1 plus imaginary angle. And 8.9 is actually the imaginary angle. And to find the actual angle of PBQ, I multiplied the measure of the imaginary angle times 2, and I got 17.8 degrees. Then I used the sum in the angles that actually helped me to do the they're always supplementary, so I did the supplementary equation, which is 3 angles in the triangle equal add up to 180, so I showed that here. So I did 180 equals PQB plus 81.1 plus 17.8 is 80 equals, actually no, I did minus, which I didn't write, I forgot to, but I did 81.1, 180 minus 81 minus the sum of 81.1 plus 17.8, so I got 81.1 as PQB. It was actually an isosceles triangle, but I didn't know that, and that's not always right, so don't do that. And then I finally added angle PQD plus BQP to get angle BQD, and I got 137.6. It's a little messy, so even I can't read what it is. 137.6 degrees. Okay, this is the explanation of the trickiest problem, number 5, which was the hardest for me to explain. But anyway, that's the way I did it, and here's the puzzle if you want to see it again, and bye.